Hi, in this session we will be discussing about exponential generative function. Already we have seen about ordinary generative function. So given a sequence a0, a1, a2, a3, etc. The generative function is also usually defined as a0 plus a1x plus a2x square plus a3x cube plus etc. Okay, so if suppose my sequence was 1, 1, 1, 1, 1, etc. Our ordinary generative function would be 1 plus x square plus x cube plus etc. Okay, so the exponential generative function is usually inspired from the exponential function e raised to x, whose expansion is 1 plus x squared by 2 factorial plus x cubed by 3 factorial plus x raised to 4 by 4 factorial plus etc. So if you have a sequence a0, a1, a2, a3 etc., the exponential generative function is defined as f of x is equal to a0 plus a1 into x plus a2 into x squared by 2 factorial plus a3 into x cube by 3 factorial plus etc. So if the ordinary generative functions, you just had a0 plus a1x plus a2x square plus etc. But in the case of exponential generating function, it is just like the exponential function. So here you will be having a0 plus a1x plus a2x square by 2 factorial plus a3x cube by 3 factorial plus etc. So if my sequence is 1, 2, 3, 4 etc., the exponential generating function will be 1 plus 2x plus 3x square by 2 factorial plus 4x cube by 3 factorial plus etc. Okay, so I hope it is clear what is exponential generative function. Okay, now for the application of this thing, so in the case of ordinary generative function, it was used to solve problems of the type like this. For example, x1 plus x2 plus x3 plus x4 is equal to 11 and your xy's were greater or equal to 0. There may be some other conditions imposed on xi. So in that you had a factor for each of these x1. So you had to choose the value of x1, x2, x3, x4 which satisfies the solution. So basically this was a combination choosing problem, or it was a combination problem there. Okay, so you need to find the values, choose the different values for x1, x2, x3, x4 which satisfies this equation and also the corresponding conditions. Okay, so you had a factor corresponding to x1, you had a factor corresponding to x2, you had a factor corresponding to x3, you had a factor corresponding to x4, and then you multiply these factors, then you found the coefficient of the, if the right hand side was 11, you have found the coefficient of x raised to 11 to find the solution. So this was the type of problems which I had discussed in the case of ordinary generative function. Okay, so on a similar line here will be discussing the application of exponential generative function where it will be applied. So basically before that, let us just look at this definition of so let us look at the briefly the expansion of 1 plus x raised to n. Okay, so before we go into the application, let us look at the expansion of 1 plus x raised to n. What is it? It is basically 1 plus nc0. Okay, so it is basically nc0 plus nc1x plus nc2x square, right? Okay, plus then you will have nc3x cube plus etc. plus nc n x raised to n. Okay, so each of the coefficient of this x square or the coefficient of x raised to r is actually NCR, so it will give you the number of ways of choosing r objects out of n objects. So that is why that is basically this is a coefficient of x raised to r gives NCR, which means the number of ways of choosing r objects from n objects, n bigger objects, n object total objects. Okay, so similarly when you write the exponential generative function for 1 plus x square plus x cube etc. Okay, so this x square means you will be choosing two objects. So basically x square means it is coming with nc2, so the factor for x square means you are choosing two objects. The factor of x cube means you are choosing three objects. So this was the basic idea which was used in normal generating functions. Okay, now if you rewrite this expansion nc1 etc. according to the definition of NCR, it will be n1 plus n by n minus 1 factorial into 1 factorial into x plus, and then it is n factorial by 2 factorial into n minus 2 factorial into x square. Okay, plus next we will have n factorial by 3 factorial into n minus 3 factorial into x cube plus n factorial by n minus n factorial into n factorial into x raised to n plus etc. plus. Okay, okay, now if you know the definition of permutations, PNR is given by, what is the value of PNR? It is actually n factorial by n minus r factorial. So if you apply that definition, this can be rewritten as 1 plus Pn1 into x, because Pn1 is n factorial by n minus 1 factorial. So Pn1 by x by 1 factorial plus, next it will have Pn2 by Pn2 into x square by 2 factorial. Okay, next you have Pn3 by into x cube by 3 factorial, etc., plus Pnn by x raised to n by n fact. So you are just rewriting the definition of expansion of 1 plus x raised to n in terms of combinations, permutations. Okay, so now you can see that the coefficient of x raised to r by r factorial gives you basically PNR, that is the number of ways of arranging r objects from a total of n objects. So in the problems involving permutations, when you have to arrange r objects from n objects, we will be looking at the coefficients of x raised to r by r factorials. In the case of ordinary generative functions, when you have to find ways of choosing r objects, we will look at the coefficient of x raised to r. But in the case of exponential generative function, here we will be dealing with permutation problems. So here, when you are trying to find number of ways of arranging r factors, you will just look at the coefficient of x raised to r by r factorial. Okay, so that is the basic idea of permutation. So in the combination problems, in these problems we are looking at the factors, we are looking at the coefficient of x raised to 11. So when you have to have a permutation problem, you will be looking at the coefficient of x raised to r by r factorial. Okay, the rest everything is that we'll see some problems and then you'll understand how we are trying to formulate this problem. Okay, so before that, let us look at some common definitions here. Okay, so you know these definitions will help you to solve some problems easier. So one definition is, you know, the definition of e raised to x, which is 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial. Okay, and e raised to minus x is, you just substitute minus x for x in the above definition, so we will get it as 1 minus x plus x square by 2 factorial plus x minus x cube by 3 factorial. So when you add these two things, you will have some terms will be cancelled out, so you will be getting this. That means e raised to x plus e raised to x minus x by 2, you will be getting only even powers, that is 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus etc. So this is normal computation, and when you subtract these two terms, all the even terms will get cancelled and you will be getting only the odd terms, that is e raised to x minus e raised to minus x by 2, which is equal to x plus x cube by 3 factorial. So these are some definitions which can help you to solving problems. Okay, so I hope it is clear what is an exponential generating function. So what is the exponential generating function for the sequence a0, a1, a2, etc.? It is nothing but a0 plus a1x plus a2 x square by 2 factorial plus a3 x cube by 3 factorial plus etc. Okay, so if you are asked to write the generating function, which is exponential generating function, I hope it is clear how to write it. Now let us do some problems related to that. So find the exponential generating function for each of the following sequence. So the first sequence is 1 minus 1 1 minus 1 1 minus 1 etc. So let us try to find it. What is it? It will be 1 minus x plus x square by 2 factorial minus x cube by 3 factorial. Okay, plus x raised to 4 by 4 factorial plus etc. So I hope it is clear, the first problem. Now look at the second problem. What is it? It is actually, can write it, it is 1 plus 2x plus 2 square x square by 2 factorial plus 2 cube x cube by 3 factorial plus etc. Now look at this problem. What is it? Again it is 1 minus ax plus a square x square by 2 factorial minus a cube x cube by 3 factorial plus etc. Okay, so you can look at these problems also, try to write down on this. Now let us look at this, let us try to determine the sequence determine following. So basically these are the closed form of the generative function, because once you have the factor of the form 1 plus x square by 2 factorial, you can write it in shorthand as e raised to x. Notice e raised to 2x, e raised to 2x is a shorthand for 1 plus 2x plus 2x the whole square by 2 factorial plus etc. And what is e raised to? So using those definitions, you can write shorthand of some things. So let us try to write down the closed form of some functions. So let us try to determine sequence generated by each of these following functions. So the first problem is 3 e raised to 3x. So how will you write it? Now what's the definition of 3 raised? So f of x is actually 3 e raised to 3x. So I can expand this as, if you know the expansion of e raised to x, 3 into 1 plus, okay, in place of x you have x 3x, 1 plus 3x plus 3x the whole square by 2 factorial plus 3x the whole cube by 3 factorial plus etc. So what is the sequence which you will be getting? It is nothing but 3 into 1 plus 3 x plus then 3 square by into x square by 2 factorial, then we'll have 3 cube into x cube by 3 factorial, or if you multiply this 3 inside, we'll be having 3 plus 3 square x plus 3 cube x square by 2 factorial plus 3 raised to 4 x cube by 3 factorial. So the corresponding sequence is 3, 3 square, 3 cube, 3 raised to 4. So this is the sequence which is being determined by this exponential generative function. Okay, now let us look at this one also. 6 raised to 5x minus 3 raised to 2x. So we have this problem: 6 e raised to 5x minus 3 e raised to 2x. Okay, let us look at the sequence. So what is it? So it will be 6 into what is the expansion of e raised to 5x? It is 1 plus 5x plus 5x the whole square by 2 factorial plus etc. minus 3 into we'll have 1 plus 2x. Okay, then we'll have plus 2x the whole square by 2 factorial plus etc. Now I don't see simplify these terms. We'll be having 6 plus 6 into 5 plus 6 into, so basically 6 into 5 into x plus 6 into 5 square into x square by 2 factorial plus etc. Minus we'll be having here 3 into plus 3 into 2x plus 3 into 2 square into x square by 2 factorial plus etc. So when you combine these terms, what will you be getting? You will be getting 6 minus 3, that is you will be getting 3, plus then you will be getting 6 into 5 minus 3 into 2 x again plus 6 into 5 square minus 3 into 2 square into x square by 2 factorial. The next term would be it will be like 6 into 5 cube minus 3 into 2 cube into x cube by 3 factorial plus etc. So the corresponding terms would be 3. So corresponding sequence would be 3, 6.5, so not 6.5, 6 into 5 minus 3 into 2, okay, plus 6 into 5 square minus 3 into 2 square, okay, plus, so next term would be 6 into 5 cube minus 3 into 2. Okay, if you want, you can simplify this, or you can write it like this. So this is the corresponding sequence. Okay, similarly you can try these problems like e raised to x plus x square. You can try these problems, so please try these problems. So if you see this problem 1 by 1 minus x, what is the corresponding exponential function? So question is 1 by 1 minus x, so it can be written as 1 plus x square by so 1 plus x square plus x cube plus etc. This is the expansion. So if you want this in the form of exponential function, it should be like 1 plus x square by 2 factorial. So I will be supplying a 2 factorial here, then x cube by 3 factorial into 3 factorial. Only then you can get in the form of exponential generating function, plus x raised to 4 by 4 factorial into 4 factorial etc. So the corresponding sequence would be 1 comma 1 comma 2 factorial, 3 factorial, 4 factorial etc. So this is the corresponding sequence of that sequence. Okay, so you can try these problems. So they can ask you determine the sequence generated by each of these following generative functions. So I hope it is clear. Now let us do some problems now. Okay, so suppose I am taking a word now. Suppose I need to arrange the words. So I am looking at this word engine. Okay, I need to arrange 4 words at a time. Okay, I will be taking 4 words out of this and I will be arranging this. Already you know from permutation how we can do this. Basically it is actually number of ways to arrange 4 letters from this words are basically total number is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So it is actually 6 factorial by the repetitions are 2 e is repeated 2 times. So 2 factorial, n is repeated 2 times, 2 factorial, rest everything is only 1. So basically 1 factorial, 1 factorial. So this is the number of ways to arrange 4 letters at a time of the word engine. Okay, now let us approach this problem using exponential generating function. This method may seem to be very difficult first, but this approach, if you understand this approach, we can use it in other problems involves permutation, which will actually simplify this thing. Actually, exponential generating function, when you apply this to this problem, it will be very difficult. But if you understand the approach to that, what is the benefit of is that you can use this type of approach to very complicated problems involving permutations. In that cases, it can be easily manipulated using this exponential generating function. So let us try to understand the approach towards exponential generating functions in doing this problem. So we are discussing the problem like we are going to arrange 4 letters, okay, of the word engine. Okay, so we'll look at this. Okay, now when you arrange the 4 letters, there are many possibilities. Or you already know that it is actually, you can take E N G I, or you can take E N E G. So basically you will be taking E, you will be taking E, you will be considering N, you will be considering G, and you will be considering I. Okay, and you can take 2 times if you want, and N you can take 2 times, and G will be taking only 1 time, and this I will be taking only 1 time. So as I told you, since we are taking only 4 letters at a time, you will be looking at the coefficient of x raised to 4 by 4 factorial, as I have explained earlier. Okay, so if you are arranging 6 letters, you will be looking at the coefficient of x raised to 6 by 6 factorial. Okay, now how to write the exponential generating function corresponding to this? So what you do is that E you can select 2 times. So basically just like ordinary generating functions, when you could if you could choose to, when you're considering ordinary generating functions, x1 plus x2 plus x3 is equal to 9. Okay, so when you select x1, if the possibility was 0, I will take 1. If the possibility was 1, I will take x. If the possibility was 2, I will take x square, like etc. up to x raised to 9. So on a similar vein, so if you are looking at E, you can take up to 2 E. So the corresponding factor corresponding to E is, if 1, when I am taking no E's, plus x if I am taking 1 E, plus x square by 2 factorial if I am taking 2 E's, because we are here discussing here exponential generating function. So every factor will have a factor of n factorial. Okay, so I hope you understand. So if there are 2 possibilities of E. If it was ordinary generating function, we will just be taking 1 plus x square. But in the case of exponential generating function, you can be considering 1 plus x square by 2 factorial. Okay, so 1 means that factor means that you are not taking any E's. So x means you are taking only 1 E, because the power of x is actually 1. So basically it means you are taking 1 E, the power of 1 is actually x raised to 0. So you are taking no E's. X raised to 1 means you are taking 1 E. X raised to 2 means you are taking 2 E's. So if there was 3 E's, there will be a factor of x cube by 3 factorial. Okay, into. Next I will be writing the factor corresponding to n. What is it? It is actually n, there can be 0 n, then there can be 1 n, then there can be 2 n. So x square by 2 factorial. Is that clear? Okay, similarly into, what is the factor corresponding to G? There either it can there be 0 G, or you can take only maximum 1 G. Okay, similarly for I also 0 G or 1 G. Okay, so corresponding to the corresponding generating function, exponential generating function of this problem is 1 plus x square by 2 factorial, okay, into 1 plus x square by 2 factorial into 1 plus x, okay, into 1 plus x. Okay, so you will have a long computation here. So you have to multiply all this, and you have to look at the factor of x raised to 4 by 4 factorial. So it's very tedious for this, but let's try to do it. So basically the problem here is, actually we will be expanding 1 plus x square by 2 factorial the whole square into 1 plus x the whole square. So I hope you understand how you have written this term. Now let us try to find the coefficient of x raised to 4 by 4 factorial. So before that, we will try to find the coefficient of x raised to 4 for simplicity. So how will you expand this? You just multiply it. So it is, you can use the formula of a plus b plus c the whole square. It is actually 1 plus x square plus x raised to 4. So x square by 2 factorial the whole square. Okay, then you will have into 2 into x, then 2 into x square by 2 factorial, plus then you will have 2 into x square by 2 factorial, because a plus b plus c the whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ac, just like our a plus b the whole square. Okay, similarly the next term would be 1 plus x square plus 2x. Okay, now we will be picking out terms involving x raised to 4 here. So when will x raised to 4 be coming? So when I multiply this x, when I multiply this x square with x square, I will be getting 1 x. So I will just write down terms involving x raised to 4. So we will have x raised to 4 there. Again, if I multiply this x square with this one, I will be getting plus 2 x raised to 4 by 2 factorial. Okay, plus now there is no term in, so when I multiply this 1 with you will have this term, you will be getting. So when you multiply this 1 with this term, you will be getting x raised to 4 by 2 factorial into 2 factorial, because you are taking square there. Okay, then you multiply this 1 with no other terms are there. Okay, plus when you are multiplying this 2x with the what will you get with x raised to 4? So basically if you multiply 2x with this term, right, this term I will be getting 2x raised to 4 by, so sorry, 4x raised to, because already 2 is there, 2x, so 4x raised to 4 by 2 factorial would be there. Is there any other more term? No other terms are. So these are the all factors. So please cross check it again once again. So these are the terms involving x raised to 4. So I can take x raised to 4 outside. So this is actually x raised to 4 into 1 plus maybe 2 by 2 factors again 1 plus again 1 by 2 factorial into 2 factorial, okay, plus 4 by 2 factorial. So basically you can write as 2, it's actually 2. So here also you can write as 4. So basically we're getting x raised to 4 into it is actually 4 plus 4 1 by 4. Okay, so this is actually maybe you can write it as 9 by 4 into x raised to 4. So the coefficient of x raised to 4 by 4 factorial would be, so I'll just supply one 4 factorial below and also above also. So this is the coefficient of x raised to 4 by 4 factorial will be nothing but 9 by 4 into 4 factorial, which is 9 into 3 factorial, that is 9 into 6, which is 54. So this is the answer. Okay, so you can try this. So please try to do this, try to write down the term. So this is the term in which you can, so you can also try if you want this problem also. So suppose I need to what do you say, abacus, I am taking this word abacus. Okay, so I need to arrange maybe 3 letters at a time. Okay, 3 letters at a time. So please try to formulate it using this generative functions. Here the 3 words are: a is there, a can come 2 times, and then b is there, okay, then c is there, u is there, s is there. This can only come 1 time. The factor corresponding to a would be 1 plus x square by 2 factorial. The factor corresponding to b would be 1 plus x, c would be that. So you'll have this thing 1 plus x raised to 4. You will be looking at the coefficient of x cube by 3 factorial because you are only taking 3 letters at a time. So you can try that problem also, abacus. So it's very simple. And now we will do some big problems in which this exponential generating function can help you. So suppose a ship carries 48 flags, 12 of each of the colors red, white, blue and black. 12 of these flags are placed in a vertical pod in order to communicate signal to other ships. Okay, so basically a ship has flags are there, so it will have poles like this, 12 poles will be there, and they will be, and you will be putting colors here. Okay, so it can be red, it can be white, it can be red, it can be blue. So basically 12 these are there. So you will be placing these things. So you will be need to arrange 12 objects. You need to arrange x 12 objects. That means you need to look at the factor of x raised to 12 by 12 factorial. Okay, so you need to arrange 12 out of this 48 flags. So we will be looking at the factor of x raised to 12 by 12 factorial. Okay, okay, now how many of these signals? So basically why is this problem a permutation problem, not a combination problem? Because you are basically sending signals. Okay, so when you are sending signals, the signal RW and the signal RRW will be different because the order of these words are important because of our communication. So when there is if it is combinations, you will be just taking only 3 red flag, 2 white black like that. But in that case, combination problems, order is not important. But in this problem, basically you are communicating a signal. So definitely there is an importance for order. So if the red is first and next red is in the second position, it will be different from the red being in the third position and red being in the fourth position. So basically the order is important in this, therefore this is a permutation problem, hence we will be using only exponential generative function. Okay, so in earlier problems order was not important, but in this problem order is important, that's why you will be using permutation. And since you have to arrange 12 of them, you will be looking at the factor of x raised to 12 by 12 factorial. Okay, now how many of these signals gives an even number of blue flags and odd number of black flags? Okay, so very simple. So you have 3 factors are there: red is there, white is there, blue is there, black is there. Okay, so BL is there and BL is there and black also is there. Okay, so there can, so since there are 12 objects, what can we say? So you need to have an even number of black flags, blue flags and odd number of black flags. So even number of blue flags and odd number of black flags. Okay, so red can be anything. So red can be no, either there can be 0 red flags or there can be 1 red flag plus x square by 2 factorial plus x cube by 3 factorial etc. plus x raised to 12 by 12 factorial. There can be actually 12 red flags if you want. Okay. Similarly, white also there is no restrictions, so there can be 0 white flag, 1 red flag, etc. So basically there is no restriction for white also, so I can multiply this, so it will be 1 plus x square by 2 factorial plus etc. plus x raised to 12 by 12 factorial. Alright. Okay. For blue flag, what they are saying, you need an even number of blue flags. So either there can be no blue flag or there can be 2 blue flag, 1 plus x square by 2 factorial or x raised 4 by 4 factorial etc. till you will have x raised to 12 by 12 factorial. Okay. So even in the case of black flags, you can have only odd number of black flags, so it will be x plus x cube by 3 factorial plus etc. plus x raised to 11 by 11 factorial. Okay. So I hope it is clear how to write this function. Okay. So very simple. So we need to write the factor corresponding to the red flag. There is no restriction. There can be no red flag to 12 red flags. Similarly, for white also no restriction, and for blue flags you can have only even number of flags, so 1 plus x square plus etc. And for black flag also you can have only odd number of flags, so it is like this. Okay. Now you are looking at we are going to look for the coefficient of x raised 12 by 12 factorial. Okay. So I am going to tweak this function a little bit. So what happens if there is a factor of x? So there cannot be a factor of x raised to 13 by 13 factorial, because you can have only 12 flags, but 12 blue red flags. But if there is a factor of x raised to 13 by 13 factorial in this term, will that affect the result? No, because you are only looking up till x raised to 12 by 12 factorial. So even if there is x raised to 13 by 13 factorial in this expression for red, it will not affect the result. Okay. Similarly here also, if you have a factor of x raised to 14 by 14 factorial also, it will not affect the result. Okay. So what is the use of that? But because if you can bring more terms like that I am extending this to infinity, 1 plus x square by 2 factorial plus x cube by 3 factorial plus etc. plus x raised 12 by 12 factorial plus, again if I am taking to infinity, this whole term could be replaced by e raised to x the whole square. Okay. So it will help you to ease the computations a little bit, because you know the expansion of e raised to x. Okay. It is easier than to multiply and find it. It is very easier to do that. So I will replace the whole thing by e raised to x. Why? Because there is no problem if there are bigger powers there, because we are only looking at the factor of x raised to 12 by 12 factorial. Okay. And similar the second term, which contains only even terms, we already know that it can be written as e raised to x plus e raised to minus x by 2. We have discussed this in the beginning of this session. Okay. Similarly for odd terms, it is e raised to x minus e raised to minus x by 2. Okay. So this is actually so the whole thing could now be simplified in this form. So I hope it is clear, because this was made possible because we can have only up till x raised 12 by 12 factorial, but even if there are bigger terms also, that will not affect the results. So if there are bigger terms, it is easier to compute the factor. Otherwise you will have to find which all factors. So since there are 4 factors are there, it is very difficult to compute it. So if you could rewrite in this form, it would be much easier to compute that value. Okay. So if you have done this, it's very simple now. So it is actually e raised to 2x by 4 into a plus b into a minus b. So it is actually e raised to 2x minus e raised to minus 2x. Okay. So this is actually 1 by 4 into e raised to 4x minus, if you multiply with e raised to x, minus 1 here. Okay. Now you need to look at the expansion of coefficient of x raised to 12 by 12 factorial. So what is this? Actually this is actually 1 by 4 into 1 plus 4x plus 4x the whole square by 2 factorial plus 4x the whole cube by 3 factorial etc. minus 1. Okay. So this is actually 1 by 4x plus then 4 square x square by 2 factorial plus 4 cube x cube by 3 factorial etc. So what is the coefficient of x raised to 12 by 12 factorial? It is nothing but it will be 1 by 4 into 4 raised to 12 by 12 factorial. That is nothing but 4 raised to 13 by 12 factorial. If you want, you can simplify it again, but I will stop it here. So I hope it is clear. It's very simple to do this form. Okay. Okay, so this was made possible only because you could use the values of e raised to 12. Okay, otherwise it is very difficult to solve this problem using direct methods. Okay, so it is very difficult to solve this problem using direct methods. So it could easily solved using it could be easily formulated using exponential generative function. Okay, let's look at this problem also. Okay, so how many signals have at least 3 white flags and no white flags at all? Okay, so here also you could try this. So same problem only, you have red flag, white flag, blue flag and black flags. You need to arrange 12 of them. So how will you formulate it? For red, blue and black, the thing is same, 1 plus x square by 2 factorial plus x cube by 3 factorial etc. plus x raised to 12 by 12 factorial in the whole raised to 3. Okay, into when there is at least 3 white flags, what will you be getting? So it no white flag, then it will be 1 will be there. So one white flag cannot happen because they have told at least at least 3 white flag or no white flag at all. So because of that, there is no factor of x there. There is no factor of x square there. There can be a factor of x cube by 3 factorial etc. x raised to 4 by 4 factorial etc. plus x raised to 12 by 12 factorial. And if you have understood the previous problem, it could actually be formulated using e raised to x because you can extend it to higher powers. So this is actually be e raised to x the whole cube into this would be actually e raised to x minus x square. So this is actually e raised to 3x into e raised to x minus x square. So this is actually e raised to 4x minus x into minus x minus x square into e raised to 3x. Okay, so you can look at this. So now look at the expansion of these things and you can try to find out what is the coefficient of x raised to 12 by 12 factorial. Please do that. So I hope it is clear what is exponential generative function. Try to do more problems, very simple section. Okay, thank you.